Okay, so today's day one for our angle basics. Okay, so we're going back way, way, way back to when you first learned stuff about angles. Okay, I even went back to kind of the beginning. Okay, as derived from the Greek language, the word trigonometry literally means measurement of triangles. Okay, so that's when you first learned it in geometry. You learned right triangle trig. Okay, but there's a whole lot more than that. Initially, trig dealt with relationships among the sides of angles and triangles, but then it actually progressed to more than that. Okay, so let's start with those angles. An angle is formed by two rays that have a common endpoint called the vertex. One ray is called the initial side and the other the terminal side. The arrow near the vertex shows the direction and the amount of rotation from the initial side to the terminal side. Okay, so all angles work this way. Your initial side is where you start your measurement. Okay, your terminal side is where you finish your measurement of the angle. Um, it makes sense, okay, because if you think about terminal, the word terminal itself, you think end, almost you think death, basically. But in this case, the angle is not dying; it's just ending there. Okay. So these definitions are going to become really important. Now, standard position. Standard position is when you have an angle in which the vertex is at the origin and the initial side coincides with the positive x-axis. And this picture right here, okay, shows we have these two rays, the initial side sitting on the positive x-axis, and our terminal side is in the second quadrant. Okay, and you can still see that arrow showing initial to terminal side. That's the other way you can figure out which one's the initial side and which one's the terminal side by the arrowhead itself. It is always pointing at your terminal or your end. Okay, so this is standard position. We often deal with angles in standard position. Okay, now central angles. A central angle of a circle is one whose vertex is at the center of a circle. Central angle, center of a circle. Okay, so now we're putting an angle inside of a circle, and you can see this one right here. We have this circle. Here's the center. Here is our angle inside of it, and this angle measure represents our angle. Okay, so this is a central angle. So when we talk about central angles, we're talking about angles inside of circles. Now, the next picture shows a central angle in standard position. So not only is our angle inside of a circle, where its vertex is in the center, it's also in standard position, which means the initial side is here on the x-axis, and it terminates somewhere in the quadrant, okay, in one of the four quadrants. Okay, so you can see how we're going to start taking some of these definitions and putting them together. Okay, so it's important that you know that if I say, hey, draw this angle in standard position, that you know exactly what I'm saying. So I should see an x and y coordinate system, and I should see the initial side on the x-axis, and then showing me where the terminal side is, and being able to tell me which quadrant it's going to end up in. Okay, so all of these are going to become important because they're going to be used to define other things that we do later. All right, types of angles. Now we're going back to elementary school. Okay, acute angles, obtuse angles, right angles, and straight angles. Okay, now really easy definitions. You should already know these. This is just a refresher. Although it is important to know there is a difference between a straight angle and a line. Okay, a straight angle is basically two rays that the angle measure is 180 degrees. Okay, versus a line is named by 2 points. So if you think about a line like this, we have the line, this is the line AB, okay, versus this array is made up of 2 points. So this ray and this ray, this would be a straight angle would be angle ABC. And there's a difference between a straight angle and a line. A straight angle will go in both directions forever and ever as well. The difference is a straight angle has 3 points. It has a vertex, and then it has 2 rays. So this is ray AB, this way is ray AB, and this way is ray BC, and together they form this straight angle, and the name of it is angle ABC, versus this, the name of this is line AB. So they're named differently because they're defined by different things. Lines are defined by 2 points, where a straight angle has to have 3 points. So there is subtle differences between those two. Okay? All right, here we go. This is going to be the first kind of thing that might be a little new. So we need to talk about positive angles versus negative angles. Okay? And we're going to talk about them in their standard position. Okay? So when we have a positive angle in standard position, the initial side sitting right here on the x-axis. Okay, here's our initial side. Our terminal side is in quadrant 2. Positive angles actually go counterclockwise. They start in quadrant 1 and go towards quadrant 2. Okay, hence that's the reason why they're actually named that way. This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. It's because that's usually the way we go when we talk about angles. Okay, positive angles go in that direction from 1, 2, 3, and then 4. Okay, they go counterclockwise. Negative angles, the initial side still starts here, but instead of going counterclockwise, we actually rotate clockwise. And if we go in this direction against the naming of our quadrants, that is what we call a negative angle. So for instance, this angle right here, this symbol right here, this is theta. Like the hurricane right now that's in the Gulf. Okay? Theta. It's a Greek symbol. We use that for angles. So this angle measure, let's say this is 120 degrees. Okay? That means we start here and we go this direction 120 degrees in the positive direction. Okay? This theta over here, let's say this is negative 120 degrees. Okay? Because we still start at this initial side and we go 120 degrees, but we're going in the negative direction. Okay? In science, they call these vectors. In science, they talk about the difference between a scalar and a vector. A scalar just being magnitude and a vector having magnitude and direction. Well, in mathematics, basically all numbers are vectors. Even when we talked about like the difference between -2 and +2, if we're on the number line, it's telling us which direction to go. Are we going to the right or are we going to the left? So in mathematics, all numbers are vectors. So this negative is telling me which direction my angle is going to go, and the 120 degrees is telling me how far in that direction. So we're going this way, clockwise, 120 degrees, and that's the angle. Versus the positive one says, hey, we're going counterclockwise. Well, how far are we going? 120 degrees. Okay? So direction is going to matter now with our numbers, especially with these angles. Okay? Now we're going to talk about coterminal angles. Okay? Now, coterminal, let's talk about that word. We just use the word terminal, and when we talk about angles, we talk about a terminal side. Okay? So let's look at this angle here first. I have a couple of them on here. But let's look at this angle 55 degrees. 55 degrees is right here. So we start in standard position. We start from our initial side on the x-axis. We go 55 degrees. Okay? Now, when we talk about coterminal, well, we know terminal means ending, right? Well, what does the co part do to it? Well, when we think about, say, co-worker or cohabitat, we're talking about a co-worker is somebody we work with, right? We work in the same place. Cohabitate means that you live in the same place. Well, coterminal angles mean that they end in the same place. Okay? So here's my 55 degrees right here. It ends right here. This is my terminal side. Okay? Now, let's look at this angle 415 degrees. Okay? This one here ends here. It starts right here. It passes 55 degrees. It goes all the way around. When it gets right here, that's 360 degrees. But then it goes another 55 degrees for a total of 415 degrees. It started in the same place. It ended in the same place. It just went a full rotation all the way around first and then went those 55 degrees. Did it start in the same place? Yes. Both started on the initial side right here. Did they end in the same place? Yes. They both ended on the same terminal side. The difference is 415 went around one time. Okay? So think of it this way. My original angle was 55 degrees. Its coterminal angle of 415 degrees. Basically, we took this angle and added 360 degrees. And we could do it again. If we took 415 and added another 360 degrees, we'd get 775 degrees. That just means that that angle started here, same place, went around once, went around twice, and then still ended up right here in the same place. It did 2 rotations and then another 55 degrees. Okay? That's what coterminal means. Same thing the other way. This other angle here, the negative angle, started here on the initial side, but went the other way. Went around this way. Did it start in the same place? Did it end in the same place? Yes. The difference is it went in the opposite direction. And if you put negative 305 here, that's because we subtracted 360 degrees. So if you take 55 degrees and subtract 360 degrees, you get 305 degrees. So basically, coterminal angles are angles that differ by a number of rotations. Okay, that's what it means. It means they start in the same place, ends in the same place. It just maybe does a lap. The way I can kind of get you guys to understand it, it's like my students. I have my really good students, I have my okay students, and I have my students that are just messing around. So for instance, if I said, hey, I need you to take this to the attendance office, and I send one of my students to the attendance office, my good kids are going to go straight there. That's my 55 degree kids. They're going to go straight to the attendance office, come straight back. Then I got my okay kids. They are going to get to the attendance office. They're my 415 degree kids. They're going to get to the attendance office, but they're going to take a little bit longer to get there. They're going to maybe swing by their buddy who's over there in physics and wave at them as they go down there, go down and come back. Or you've got your 775 degree kids that are basically, that's the kids that are going to go, okay, I'm going to go. They go all the way to the north side, through the C building, come back around, go over there to the LGI and the north side, come all the way back, hit the attendance office, and then come back to my room. And then they get there. That's the difference. Did they all get back and get to where they needed to go? Yeah. Did some of them take longer to get there? Absolutely. It just takes how long it takes to get there. Okay? That's what coterminal angles are all about. So, basically, when we have an angle and we say it's coterminal with all angles, when you take your angle and add 300 or subtract 360 degrees. N represents the number of rotations. Okay? So if it rotates once, if N is 1, you're 360 degrees difference. If N is 2, you're talking about 720 degree difference. If N is 3, it's 1,080 degrees difference. Okay, that's all it's saying, is that if you're finding a coterminal angle with another angle, all you do is add or subtract 360 degrees. Okay, so here we go. So name two coterminal angles, one positive and one negative with 30 degrees. So we're going to take 30 degrees, we're going to add 360, and we're going to take 30 degrees and subtract 360. So when I take 30 degrees and add 360, I get 390 degrees. When I take 30 degrees and subtract 360 degrees, I get negative 330 degrees. And both of those angles start in the same place and end in the same place with 30 degrees. They're just different by one rotation. Okay? Same thing with this angle with 120 degrees. Add and subtract 360. So 480 and negative 240 are coterminal with 120 degrees. Negative 45 degrees. When we add 360, we get 315. When we subtract, we get negative 405. Okay, that's coterminal angles. All right, now let's look at reference angles. Okay, what is a reference angle? Well, a reference angle is basically when you have angles greater than 90 or less than 0, we use reference angles to basically find where they are in the quadrant to make it easier. Okay, so let theta be an angle in standard position. Its reference angle is the acute angle formed by the terminal side and the horizontal axis. Okay, so let's look at what that looks like. Okay, these are our reference angles in each quadrant. We don't have to do quadrant 1 because the reference angle is the angle, because all the angles in first quadrant are less than 90 already. But if we're looking at quadrant 2, okay, if this is our actual angle, and let's say this is 120 degrees here, that means our reference angle is this angle over here. And if this is 120 degrees here, and this whole thing, if you remember, is 180 degrees, that means our reference angle is 60 degrees. Okay? So basically, that all of that was saying is that when you find your reference angle, it's the angle measure telling you how far your terminal side is from the x-axis. Okay? So in quadrant 2, like we said, this distance right here from the terminal side to this x-axis is our reference angle. In the third quadrant, our reference angle is this angle. How far is it from this x-axis to this terminal side? Or in quadrant 4, this is our terminal side, this is our reference angle, this little piece here. Okay? And these are the equations right here that we use. So just like what we did right here, we said, wait a minute, this whole thing is 180 degrees. If this is 120, this is 60. You took 180 and you subtracted your angle. Here, you take your angle and you subtract 180 degrees from it, and it'll give you this extra piece. In the fourth quadrant, you take 360, which is all the way around, and you subtract whatever this angle measure is this way, and that'll give you your reference angle. So we're just finding how far it is from the x-axis. Okay? And that's what a reference angle is. So, for example, find the reference angle for 300 degrees. So the first thing you do is you take your 300 degrees, it lies in quadrant 4. Okay? So you take the equation 360, subtract 300, and that's 60 degrees. And this is what it looks like. So here's my angle, 300 degrees. It starts here, it goes all the way around to right here. Well, the reference angle is this piece right here. Well, we know all the way around is 360 degrees, so our reference angle is 60 degrees in the fourth quadrant. And we'll go more over what we're going to use these for later when we go over the unit circle. But for right now, you just need to know the definition and how to find these reference angles in each quadrant.